So here's the raw material for our experiment. We have two discs, and this is the wall and the center column of our underwater room, and this is just the stuff for stiffening it out, which is still getting cut and cleaned. So this is 1/16 material. The theory says that if you have a exact scale image, then it will collapse at the same depth as the original room or the original hollow body. So we instead of a 1:1 model, we use a 1/8 model. So the wall strength is also 1/8. In that case, 1/16. So in the original room, we are using in part 15mm material. So with that, we are on the safe side. So we use the weaker material throughout. Now the parts are welded together. The end discs have their stiffening, just like it would be in the original one. Here too. So now we are going to weld that close. So the main spar is just a stub, because the spar is not actually what we want to test. The main thing is does the cylinder part collapse, or does the end disc collapse, and at what depth. So if you can exceed a depth of 2 times what we plan to put the original cylinder in, we're gonna be happy. Okay, we have the crash test dummy ready for the dive test. It's hanging on that little crane of our boat, the Deus Ex Machina. And that young gentleman is going to run the operation. So now we are attaching the drones and then let it down. Okay, so this time with the bots attached, they are going to film the collapse, we hope. So we got it back up, and now we are disentangling the cameras. So it was spinning around, so the umbilical of the cameras is wrapped around the main rope. And we have to unentangle that, and then try to get it out. Now it's about double weight as before, so we are at more than 300 kilo with all the water in the compartment. Okay, in conclusion, we had the first buckling at around 19 meter, and the complete collapse, like we see it here, at around 25 meter. The model got leaky with that little hole here, and that is the result of that not being welded to the cylindrical walls. This is actually a reason why we are going to be on one of the reasons why we are on the safe side with that model. The L beams are only tacked to this area here, to the ceiling and the bottom, while in reality the angle shapes, like here we see the print of one, they will be welded to this wall in the real model. So it was a bit of a surprise that the cylindrical wall collapsed first. I expected buckling to happen actually at the top and or the bottom first, and then model buckling. This is actually a result of this wall folding in, that this is now deformed. This is not a buckling by itself. So it shows the regular pattern that we expect. As said, we are on the safe side. The difference is this is 1/16 inch. In a 1:8 model, this corresponds to a half-inch sheet, but for the bottom and this wall, we are going to use 15 millimeter instead, which is slightly more, and that puts us on the safe side. And also there is going to be a bunch of stiffening elements like the windows in this wall. So for the real underwater room, the collapse would occur a bunch of meters deeper. So we're in good shape.